Next part is talking about the maximum average power. And the maximum average power, this is related to the maximum power transfer, which is when you use Thevenin. So I'm assume that you have a circuit like this linear circuit connected to ZL. So in this case, if you want to get the maximum power, then you have to connect this ZL to the circuit, and ZL equals the conjugate, the complex conjugate of Z7N. Okay, which is the same like Z7N, but you just need to flip the sign of the complex number, J. So instead of negative, make it positive, positive, make it negative. Okay, so ZL is the same like Z7N, but it is a conjugate. You just flip the negative, the imaginary part. That's it. So here ZL equal RL plus JXL. So it is the same here. R7 is the same R7, but the X will be negative. That's it. X will be negative. So now if you look at the circuit, Z7 and ZL, the total impedance is what? Is that because the imaginary will cancel each other. So the total will be 2R7. So if you want to calculate the current, for example, what is the current? The current is V7, is V7 divided by 2R7. 2R7. Okay. So in this case, PL max equal what? Equal, actually it is a power in the ZL. This is a power in this ZL, which is the conjugate of Z7. So it is divided between, they have real and imaginary. So it will be PRL plus PXL. This PRL and XL. And you know that this part here will be 0. Why? Because it is a complex number. It is either capacitor or inductor, so it will have no power. So the total power will be PRL. Okay, so PRL, which is the same like PR7, the same. Okay, so in this case, if you want to calculate the maximum load power, it is 1/2 I square R7. Okay, you can calculate like this: current square time R7 and 1/2 here, because this is actually is AC. So the current here, what's the current? The current is V7 divided by 2R7. V7 divided by the total impedance, which is 2R7. So you can, if you substitute by this one here, so the maximum power is V7 square divided by 8R7. Okay, how do we get this? We get it using from this relation. We know that here it is 1/2 I square, which is V7 square, okay, divided by 2 R7 square will be 4 R7 square, okay, and you multiply this time R7, so time R7. So it is very clear that R7 will cancel with one of this square. Then you end up with 1/2 V7 square divided by R7, 4R7. And 2 times 4 is 8. Okay, so if I want you to calculate the maximum power, so what you need to do is just find Z7 and get R7. Then PL max equal V7 square divided by 8R7. You just use this formula. This is an example. So here find PL max for ZL. Okay, ZL. So don't know ZL. Of course, you know ZL because you have to figure it out. ZL is just Z7 conjugate. Okay, so we need to find Z conjugate. So to find Z conjugate, here is the circuit. Here is the circuit. So 4 and 8 minus J6 are parallel to each other. 4 ohm and this one here, 8 minus J6. So they are parallel to each other. And then you add it to J5. Then Z7 equal what? Equals this J5, this one, plus 4 parallel with 8 minus J6. So what you need to do is to multiply 4 and 8 minus J6 and divide by the summation. So this is what I did here, 4 times 8 minus J6 over 4 plus 8 minus J6. And then you try to simplify this. This is just complex numbers. And then find the total. The total will be 2.933 plus J467. So how do you do that? You just say 4 times 8 is 32 minus 4 times 6 is 24. Okay, and then you convert this to real and amplitude and phase. And this one is 4 plus 8 is 12. 12 minus J6, you convert it also to amplitude and phase, and then divide. Okay, it is a little bit lengthy process, but yeah, it's not hard to do. Okay, so let's see here. How can we do this? Okay, so here it is. So let's see. So again, it is you have 32 minus J24 divided by 12 minus J6. Okay, so you can just use the calculator here to calculate the amplitude and phase. So you have 32 square plus 24 square equal, and this to the power 0.5 or square root will be 40. So this will be 40. And what is the angle here? The angle will be 24 minus divided by 32. Okay, and this is inverse 10. So it is negative 36.8, almost 7 degree. Okay, so this is the first one. The second one here is 12 square plus 6 square equal 180 to the power of 0.5 equal 13.416 or 2, and angle equal what? Equal negative 6 divided by 12 inverse 10 is negative 26, negative 26.565. Okay, so now this equal what? Equal 40 divided by 13.42 equal 2.98, and the angle here is what? Is 36.87 minus, and this is minus will be plus 26.565, which is negative 10.3. You can neglect the 5 course, or you can just leave it like this. Okay, so you can write this one again in terms of what? Of real and imaginary, because you have to add J5 to it. You have to add J5 to it. So you can say, okay, this equal 2.898 time negative 10.305 cosine. So it is 10.305, and it is negative cosine equal 2.93. Okay, 2.93, and then 2.98 time negative 10.305 negative, and hit sine equal negative 0.5. So it is minus J 0.533. Okay, so this is this part here. Add this to what? Add this to plus J5. That will be, of course, 2.93. I hope I did not do any mistake. Okay, plus, of course, plus what here? Plus 5 minus this one will be 4.467. J, of course. That's it. So this will be the total impedance. This will be the total impedance, and you need to flip this back to real and imaginary, to amplitude and phase. So you can say, okay, this is 2.93 square plus 4.467 0.467 square equal, and to the power of 0.5. Here it is. So it is 5.3. Is it 3? I don't know. 5.34. And the angle equal what? The angle here is 10 minus 1. 4.467 divided by 2.93. And you hit inverse 10. Okay, so it will be 19 degree, 19.3. I believe 4. Yes, 4, no, 6. Okay. So this is supposed to be the answer here. This is the answer. Yes, we got almost the same answer, yes. At least for this part. Okay, so now this is D7N. So this will be R7N and this will be X7N. Then in this case, if you want to calculate V7N, so this is the first part because we need R7N. We need this 2.933. We need it here. So we need the next part is V7N. So what is V7N? Equal what? Equal the you have a current here. For this circuit, you do not have a current here. This one. So it is this current time what? Time this resistance here, or impedance, which is 8 minus J6. So it is the same here. It is 10. The voltage is 10 divided by the total impedance. This is the current actually. This part is the current. Okay, here they use voltage divider. It is the same. There is no difference. 10 divided by 4 plus 8 minus J6. This is the total impedance. So it is the total current here. 10 divided by 12 minus J6 multiplied by this one here will be 8 minus J6. You multiply this and it is, you can do the same process again. You finally will get this V7. So V7 is 7.454 and so on. And the angle negative 10.3. Then the Pmax equal what here? Blmax equal V7N square, which is 7.454 divided by 8 times R7N, which is 2.93. Then this will give you the maximum power in the load. So, but the load here is a conjugate of the 7N impedance. So the last slide here, this is assignment. The assignment consists of all the examples that we have solved here. So you don't have to, this is not new problems. So what you need to do, just try to, but please try to understand the solution. Okay, because in the quiz you may get different problems.